Okay, just a little bit of last minute advice for excellence. So let's have a look. Time-wise, it could be quite tight, so make sure you know what's expected and display those excellent skills. You should have the finding of graphs down to quite a fine art by now, so try and be efficient without too many words, but making sure that you've got all the right language. So you don't want to be writing more than the space. If you've got a situation where you're actually modelling a design, then you want to think about making things connected to each other. So for example, the model answer on this one, we've got a parabola, and then another parabola, another parabola, another parabola, and they all have the same k value. So they're just a translation, vertical translation of each other, and the domains change. So that's a little bit of attention to detail. For excellence, you want to at least have a couple of functions where you have the ranges correct. Now, if you get a situation where you get the chance to display, choose things to do, you want to show off your skills. So if you show off your skills, you need to know this grid really well. So, what do you have to do for excellence? You need 2 equations, you need 2 graphs, and you need 1 or 2 others. Make sure that 2 of them are done beautifully, absolutely comprehensively, which means you've got all of the features of the graph, you've got the domain, you've got the range, you've got the transformations, you've named the base function. The domain in words is for achieved. The domain for merit and excellence, you want to be using mathematical language. So if you've got your x between 2 values of a and b, if a and b are included, we use that. And the other way of writing that is a comma b, with the square brackets being included and the round brackets being not included, so that would be more like that syntax. So it's a matter of spending a bit of time on getting your syntax correct. Now, the real fun part for excellence comes in these. So you might choose to add a combination graph if you get the chance. Reflection, what that's talking about is reflecting in the x-axis and reflecting in the y-axis, and so it really is a matter of making that connection. By inverse, what we're meaning is swapping the x with the y. So for example, y equals x squared. If you swap it round, you get x equals y squared, so y equals plus or minus the square root of x. So connecting that with the mirror image through the line y equals x and discussing it would get you a tick for inverse. Reflection in the x or y axes, or both, would get you a tick for that. Generalise is actually quite easy to get if you're stating the base function and then the generalised transformation function. So for example, for your parabolas with a vertex, you would do, let's see if I can make some space. Yeah, let's just write it here. And we could go y equals k x minus a squared plus b. That's actually the generalised function where the vertex is a comma b and k is the vertical shift. So by writing that equation and connecting it, I've actually done the general formula. So that's quite an easy tick for most of you. So note, for excellence, you only need 3 codes. For merit, 2 codes. You're not trying to do everything, but you are trying to get clarity. You may not finish, but you could still get excellence, but what you do needs to be very clear. So in order to get finished on time, you might have to be quite concise to gain the completeness. So I'm not looking for a huge essay, it's got to be realistic. So for excellence, 3 out of the 5. Inverse, reflection, intersection, combination or generalise. Okay, so that combination just means a combination graph. For example, we had a parabola added to a sine wave which ended up with or something like that. You might get the chance to add something like that in and then explain well enough to get your E. So we're really looking for a depth of understanding. Now, if that's all very confusing, what we can go back to is the actual standard. So this comes from the standard itself. Have you applied graphical methods in solving problems? And of course it does have to be at year 12 level. Have you applied graphical methods using relational thinking in solving problems? So relational thinking, you're actually making connection between different ideas, you're able to articulate it, and you've got way more thorough understanding. Extended abstract is that kind of thing where you've got the opportunity to show off your skills. You actually have to think to do it. It's a little bit outside the square, and a little bit of prior knowledge of knowing what you need to show is good. Now the standard's massive. Our focus on this assessment is the understanding of concepts and identifying the concepts in context. So an example here was knowing about your transformations, but here actually using them. So if I had my parabolae all with the same k value and perhaps the vertexes were just vertical shifts of each other, to be able to do that and articulate it is really important. And then the attention to detail of these changing domains and ranges would be good. Of course, the range for this, you're getting into excellence level thinking in a way, because you've actually got to use the y coordinate of the vertex as the highest point, and you would have to sub in the x value to get the lowest y coordinate, and you might have to do it both sides depending on whether this is symmetrical. And those are other ideas, things like all parabolas have symmetry. So I don't know if I've confused you more than ever, but good luck, and there's a few extra notes there.